So this exercise is related to paper 6 force extension questions, and we'll do question 1 from this. The points which you should remember, like for a fair comparison, what are the parameters that should be kept constant? What are the precautions for these experiments when we are measuring our extension or the length or the change in the length? So the first question, a student investigates the stretching of a spring. You can see the student investigating how the spring stretches. And figure 1.1 shows the apparatus. A 0 centimeter mark is there. A meter rule is beside the spring. The meter is clamped in a position near to a spring. Write down the scale reading in millimeter. It's a meter rule. Meter rule maximum it can measure 100 centimeters. So this is in centimeter. Like 44 is not millimeter. 44 is centimeter. Because it's 100 centimeter marks are there from zero, like start till the maximum, that is 100. So we have to convert into millimeter. Write down the scale reading in millimeter from a meter rule at the top and at the bottom. So you can use screen annotation. Just a minute. You can use screen annotation now. So what is there at the top and what is there at the bottom? It's not exactly at 44. It is 43.9. This point, if you see the top reading, it's not at 44. It is above 44. So it is like 43.9. So 43.9, but we have to convert into, so this one is 43.9 centimeter, but the answer we have to write in millimeter. So we multiply by 10. So it will become 439 millimeter. And the bottom is like 45, 46, 7, 8, and 9. Like 0.5, 0.1 is there. So 45.1, 45.2. This is 1, 2, 3, and 4. So 45.4. So 45.4 centimeter, when we multiply by 10, it will be millimeter. So 454 millimeter. So the two values are correct. Yeah, every mark is 0.1 centimeter. By mistake, because I just thought it's written as 45, 46, but because between 44 and 45, there are 10 marks. So that's why each mark is 0.1 centimeter or 1 millimeter, you can also. Use the two readings, calculate the L naught, the length of a spring. So what will be the length of the spring? If one of the value, if the top reading was 439 and the bottom reading is 454, what is the length of this spring? How long this spring be? If one is 439, another one is 454. So the length of the spring, basically we take a difference, so L naught, and what we have to do, it is 15. So what we have to do, we have to write this 15 in table where L is equals to 0. So in the question when load is 0, we have to write here. So we will write 15 here. So 15 millimeter, the length. The next part, so this is 15. The next part we'll do in sequence. The extension here, that's correct. But then the student suspended the load 0.2 and from the spring, and he record the new length in a table. And extension is the new length minus the original length. This is question number 1 from topic force and extension. Force and extension ATP, question 1. So we have to complete the column heading. and we have to complete the extension. So what will be the extension here? It was originally 15 and now after 0.2 it's 17. So how much is extension? So that's equal to 2. So 2 is the extension. Then we have to complete the column heading. Column heading means like the units here. We have the extension, but because the length is in millimeters, so extension should also be in millimeter. That's why we write E then slash mm, millimeter. Whenever a question is there, complete the extension column heading. What is the meaning of a column heading? Column heading means unit. Because you're calculating an extension, how extension is calculated? Extension is the new length minus the original length is the extension. So the new length is 17 and the original length was 15. So 17 minus 15, that's equal to 2. But what about the unit? Because the length was in millimeter, so extension should also be in millimeter. So that's why we write just the unit as millimeter. If length was in centimeter, extension will be in centimeters as well. Why 2? Because if you see the original length, when nothing was attached to a spring, if there was nothing attached to a spring, it was having a length of 15. When we add a load of 0.2, so when a load of 0.2 or 0.2 is added, the length of the spring changes to 17. So how much the size has increased? So originally it was 15 and now 17 millimeter. So how much the size has increased? That's called extension. So it's equal to 2. The next one, we have to plot a graph for extension in millimeter and load in Newton, and load should be on x-axis and extension on y-axis. So first thing, important thing is selecting a scale. The most important part is selecting the scale. For the how to select a scale, because you check the minimum and the maximum value. The minimum value is 0 for load and the maximum value is 1. So I want, and you, whenever you're plotting a graph, you should cover 70% of your graph paper. 70 or more than 70% of your graph paper. You should cover that. And load is on
Mr. Can it
x-axis.
be 0.05?
The smallest value 0.05. Yeah, it can be. I will select a scale here. See. If so, minimum value is 0 and the maximum is 1. So after every 10 boxes, or after every 5, because I should know the number of the boxes. Like example here, 1, 2, 3, 4, 5. So example, this I took as 0.1. Then another 5, 1, 2, 3, 4, 5. I took 0.2. Then another 5, 1, 2, 3, 4, 5. I took 0.3. Then 0.4. Then 0.5. 0.6. 0.7. 0.8. 0.9. 1, 2, 3, 4, 5. 1.0 or 1. You don't have to draw an arrow. I just draw an arrow to show that this is an x-axis. So x-axis, we will label the x-axis and then I will write. You just have to mark the points here, like after every 5 boxes equal to point mark. And because my scale cover about more than 70% of the axis, it means this is a right scale. Whenever you select a scale, your scale should cover 70% or more than 70% of the axis. And then you write Newton. because the x-axis you have Newton and the unit like load is there and the unit is Newton. So L/N. L is the quantity which you plot here and N is a unit that is in Newton. Is it clear this part?
Yes, sir, clear.
So here I have 0.1, then after 5, 0.2, this will be 0.3, this was 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1.0. So I have the axis. Yeah, each is representing 0.02 Newton for one block. That's right. So we label the x-axis, and when you label the axis, you should mention, like example, this is load is there and the unit is Newton. And better draw a line. A line should be there on the axis, like representing our x-axis. So draw a line here. You can make an arrow, that's also fine, but without arrow, it's also okay. Now for y-axis, I have to make extension. The minimum value is 0 and the maximum is 13. So I have to extend my scale. Minimum I need 0 on my scale, and the reason for making a line is just to identify the axis. That horizontal line is x-axis and the vertical line is y-axis. So I want from 0 to 13. So you have to select a scale. If you select, like example, 10 boxes equals to 2. If I select 10 boxes equals to 2, so like this will be, this was 0 for x-axis as well as the 0 for the y-axis. Then 10 boxes equals to 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I just missed count maybe. So if I select 10 boxes equals to 2, then another 10 boxes equals to 4. Then 6. 8. 10. 12, and then 14. So means I have my scale and I'm covering about 70% of the graph paper with my scale. So that's also correct. And you should label the axis. So it is extension, and what is the unit of extension is in millimeter. So draw horizontal line to show an x-axis. Then draw the vertical line to show the y-axis. Now what we have to do, we have to plot the results on the grid. So we have to plot this results on the grid. Now the values, I will rewrite the value here so I don't have to scroll. It is 0, 0, 0.2, 0.4, 0.6, 0.8, 1.0, and that is 2, 5, 8, 10, 13. No, you cannot put the exact value on the graph. That is totally wrong. The way to plot a graph is not to, like, it's not like you see 15 and you write 15 on it, or you see 2, you write 2. That's the wrong way of plotting a graph. For a graph, you select a scale, then you find the points on the graph and then match those points and draw a line of a best fit. So first one, 0.2 and 2. Maybe because of a screen, my points might be up or down, but I will try to use the exact value. 0.4 and 5. So 0.4 and 5. So it will be 5 boxes above 4. Then we have 0.6 and 8. So this is 0.6. Then we have 0.8 and 10. And then we have 1.0 and 13. Here I took 10 boxes. I took 10 boxes equals to 2. So each box is 0.2. So it will be 4.2, 4.4, 4.6, 4.8, and 5. Because I took 10 box difference. So that's why 5 boxes equals to 1. And then 1 and 13, or 1.0 and 13. So this is 12. Then 1, 2, 3, 4, 5. So this will be 13. So what we will do, because we know force and extension are directly proportional, so we'll plot a line of a best fit, and it should start from origin because the first point is 0, 0. That is also you have to mark. The first point on the grid is 0, 0. So that's the first point. So we'll draw a line of a best fit. Line of a best fit means like number of the points above and below should be same. As you can see here, when I draw the line, if 2 points appear to be above, 2 points appear to be below, and one of the point is lying on the line. And it should start from origin. So after marking a point, what we did, we marked the point because we have the load and extension. So this was a load and this is extension. So line of a best fit means like you should draw a line. It's not like you should have maximum number of the points on the line. It's like number of the points which are above the line and below the line should be same for a line of best fit. So you can see these 2 points are above the line. These 2 points are below the line. And one of the point is lying on this. Because we know force and extension are directly proportional, so there must be a straight line. So we may have a point scattered. So what we do, we will draw a line of a best fit. Line of a best fit means like the points which are above the line and the below the line should be same. You cannot do point to point. This type of graph is not acceptable at all in physics. That what students usually do is joining one point, then the next point, then next point. This is totally wrong. This is not at all how we plot any kind of graph. This is not a this freehand graph only we do like this, but freehand graph normally it is a curve. But as we already know that the force and extension, it should be a straight line because force and extension are directly proportional. So how we plot a graph for force and extension, it should be a straight line and starting from origin. So why we choose line of a best fit? Because the points might be scattered. Because when the student did the experiment, there might be a parallax error. There might be like the ruler may not be vertical. Maybe the spring was vibrating when he was measuring the length. So he may not get the correct value because, because the errors are there, systematic or random errors. So due to the errors, the point will not never lie. Practical, theoretically, force and extension, the point should always be a straight, like point should lie on the line theoretically, but practically, because there are errors involved, so the points won't be in a straight line. There might be slight scattered a bit. So what you have to do, you have to draw a line of best fit. Is it clear, this part? How you can identify that scale, which point you should, you have to place a ruler or the scale, and it's not necessary you touch the last point. It is not necessary you touch the last point. The line of a, when you place your ruler or the scale and you try to, like example, if I draw a line like this, is this a line of best fit? Yes or no? Is this look a line of a best fit? So when I draw a line of a best fit, it won't be a line. Like when I draw like this, it's not a line of a best fit. Why? Because all the points are below the line. If I draw a line like this, does it look like a line of best fit? No, because all the points are lying above the line. So when I join a line and I have equal number of the points above and below, it means that is my line of best fit. And it's not necessary that we should join the last point. Even last point can be above or below. But the idea of a line of a best fit that we should have same distance or equal number of the points above and below. Is it clear, this one?
Yes, sir, clear.
Yes, sir.
The next part after plotting a graph. So that is the only part, like we just have to plot a graph. Sometimes they ask to calculate the gradient as well, but not in this one. So we don't have to. The next one in figure 1.2 shows the unstretched spring and the spring with a load. On a figure, how distance L0, L and E are measured. So L0, that's good. L0 is the distance of the unstretched spring. L is the distance of L is the distance of, we don't have to mention L0 again here. L0 you already mentioned. So L0 is a distance from of unstretched spring. L is the distance of the stretched spring. And what about the extension? You should measure the extension from the same point. Like example, if I'm measuring from the lower loop, so I'll mention from lower loop as well. So this will be the extension, how much increase in length. Is it clear, this one?